Okay, question 3. So question 3 is a lovely third equation. So this was from the second chapter. So the first thing we're going to do is we're going to square both sides. Okay, the key thing here is going to be making sure that when we're squaring both sides that we are doing it properly. Okay, so let's just take that second to write out exactly what we're doing. So we're just rewriting the sum, and I'm showing that what I'm going to do is I'm going to square both sides. The reason I'm taking this extra step, I suppose, or this extra just minute to really write out exactly what I'm doing, is just to make sure that when I do square out both sides that I don't accidentally miss something. So starting with the left hand side here, I'm going to first get 3x minus 2. Okay, that's coming from the square root of 3x minus 2 multiplied by square root of 3x minus 2. Then I'm going to have 4 minus 4 square root of 3x minus 2. And finally plus 4. On the right hand side, I'm just left with my x minus 2. That middle term is the key one. Okay, that middle term is the one that could be forgotten. And it's similar to when you're doing your quadratics and when you're multiplying out brackets like x plus 2, that you would have been told not to forget the middle term, the middle x term. And this is similar to that as well. So it's just making sure you don't forget that middle step. Once we've got to this point, we're going to maybe just tidy up this left hand side a little bit. So we get 3x plus 2 minus 4, 3x minus 2, again equal to x minus 2. We're going to try and get everything over maybe on one side. So I want to have my third equation on one side, I want to have everything else on the other side. So let's, on this side we'd have 2x plus 4, and on the other side I'm going to have 4 square root of 3x minus 2. At this point there is not an awful lot more that I can do, so I'm going to square both sides again. You could divide by the 4 there if you wanted to, and that would be equally fine, but I'm just going to go ahead and square both sides at this point instead, because otherwise I'll be kind of squaring fractions and things like that. So on the left hand side I'm going to get 4x squared plus 16x plus 16, and on the right hand side the 4 squared gives me 16, that's multiplied by that 3x minus 2. Okay, then multiplying that out, so 4x squared plus 16x plus 16 is equal to 48x minus 32. We're going to rearrange that a little bit, so we have 4x squared minus 32x plus 48 is equal to 0. We can then at that point divide across by 4, just to again make it a little bit easier for ourselves to solve the quadratic, just to make it a bit easier for ourselves to see the roots. So we have x squared minus 8x plus 12. Putting that into a quadratic, or putting that into its roots, I suppose, x minus 6, or factors, I suppose would be the more accurate term. X minus 6, x minus 2 is equal to 0, and what that means is that x is equal to 6, or x is equal to 2. And those are our two answers for this question. What we should remember with these third equations as well is that once we have an answer, oh, I lost my screen, there we go. Once we have an answer, we have to check the answer. So let's just take the time now to do that. So we have to check that they're both valid solutions, because even though you get your answers by solving the quadratic, by working all that out, we found in class that sometimes when we did the questions we don't always have a valid answer. So even though we're saying x could be 2, when we actually sub it back in, x can't be 2. So we have to just double check and make sure that we're happy with it. So let's start with the 6 first. So anywhere I see x, I'm going to sub in 6. I'm just going to make sure that it is a valid solution. So on the left hand side here I have 18 minus 2 minus 2 is equal to square root of 4. square root of 16 minus 2 is equal to square root of 4. 4 minus 2 is equal to 2, and 2 is equal to 2. So that is valid. My other answer was 2, so let's give that one a go. So if we sub that in, okay, so we're looking at the square root of 6 minus 2 minus 2 is equal to the square root of 0. So the square root of 4 minus 2 is equal to 0. We're saying 2 minus 2 is equal to 0, and 0 is equal to 0. So we just add a little note down here and say both valid solutions. Okay, that check at the end is what would take you from maybe 12 marks to 15 marks in that question, or maybe 10 to 15 marks. You know, there could be 5 marks going for that last little bit of checking your answer. Okay, so it is important to take that time to go back to check that they're both valid solutions, because you've put in the hard work to get that far, to get the solutions. So sub them back in just to make sure that they are both valid. The part B for this question was going back to forming a quadratic from its roots. And we kind of have two different ways of doing this. The first one is using that formula that we had in class. So it's x squared minus the sum of the roots, x, plus the product of the roots. Okay, so if we give this one a go, and just being careful as well, there was a little bit of a typo here, that was just supposed to be a plus and not an equal sign. I know that threw some people off. So x squared minus the sum, so we're saying 3 minus a half. I know that's a minus, but it's still the sum of the two of them. And then minus a half multiplied by 3. Okay, following that through, we get x squared minus 5 over 2 x minus 3 over 2 is equal to 0. Okay, and that essentially is our answer. What we should do with these questions, and it wasn't explicitly said in this one, so marks were still given for that answer, but what we should do at this point is we should multiply across by the 2 to eliminate the fractions. So instead of our fractions we have a full quadratic. And then we take the time then to write out what A, B and C are. Okay. The question asks us to find the values of A, B and C, so it is important that you really explicitly write those out, as I've done here at the bottom. So whether you did that for this version as I did, or did it for the version before, you needed to write out those values of A, B and C to get your full marks. Okay, so 5 marks for that question. The other way, if you couldn't remember that formula, is to kind of work backwards from our quadratic. So with our quadratics, this is usually where we end up. So minus a half. This is usually where we end up. This is usually the last step of our quadratics. So we can move maybe a step backwards and rewrite this as equal to 0. And same here, x minus 3 is equal to 0. And then with our quadratics, we usually had the two brackets beside each other as a sum being multiplied. And then we can multiply out the brackets. And what you'll see here is you're actually doing the same thing. This is where the formula comes from. And we get the same answer, x squared minus 5 over 2, x minus 3 over 2. And then you do the same as we've done over here. So you could multiply across by the 2, you would rewrite out A is equal to, B is equal to, C is equal to. But either of those options are grand. The right hand side might be one that you'd remember better than the formula. It's where the formula comes from. The formula itself is useful for particular types of questions where maybe one root is bigger than the other, or you're given a certain condition on the roots. But for one like that, where you're just given the two roots and you're asked to find the values of A, B and C of the quadratic equation, you could just follow it through as we've done there on the right hand side.